Section 9.2, Addition and Subtraction Identities. The objectives that we're going to do are to use the addition and subtraction properties, or identities, I should say, for sine, cosine, and tangent functions, and use cofunction identities. So let's do a little exploring. Say we have the sine of x plus pi over 6, and we want to figure out if it's a possible identity with the sine of x plus the sine of pi over 6. So we're going to put this side into y1, and then this side we're going to put y2 into our calculator in order to determine this, because it's graphically determining. So if I go to my calculator, notice I put it in y1, y2. Make sure your mode is in radian mode. Notice that I made y2 a little bit thicker of a line, so when I graphed it I could see if it's on top of each other, if it is an identity. And then of course I like to hit zoom 7 for a nice trig window. So here's my first graph and my second graph equation, and because they're not exactly the same, and I know I plugged in correctly into my calculator, I know that this is not a possible identity. So if I go over here, I'm going to say it's not an identity. Well, if you look at this, this is a common mistake that students try to make. Notice if I have the sine of x plus y, it is not going to be equal to the sine of x plus the sine of y. So you cannot distribute. You can't do this. This does not work for this equation. So do not distribute. And this is for this problem that we just did. Instead of saying y, because we can't do x and y in our calculator, that's why we plugged in pi over 6. So do not distribute when you're doing these problems. So let's go ahead and take a look at this next problem, and you guys should plug this into your calculator. I'm going to plug it into mine. So after I plug this into my y equals y1 and y2, then I'm going to hit graph. Don't forget, make sure that you're in radian mode. So here's my first equation. And look at my second equation, they're right on top of each other, so then we could say that, yes, this is a possible identity. So when I go over here, I'm going to say yes. So let's see if we can come up with the equation that makes this a true statement to actually give me my identity values. Remember that the cosine of pi over 6 is really root 3 over 2, which is where we get this right here, and the sine of pi over 6 is equal to 1/2, which is where we get this right here. So if I wanted to write the equation for this, I know that pi over 6 instead could be y. So notice that if instead I did the cosine of y times the sine of x plus the 1/2 would stand for the sine. So I'm saying let y equal pi over 6. So the sine of y then would be times the cosine of x. And this is the identity that we're getting for this, which I'm going to write out a little bit better in just a second. So if we were to plug this next one into our equation and plug in the actual values, you would see that from this we can come up with these identities that we have. So the addition and subtraction identities for sine and cosine. If you have sine x plus y, again, do not distribute, but the identity for it is sine x cosine y plus cosine x sine y. So notice that first we do the sine of the first angle and then the cosine of the second one, and then you switch the two. So if you have minus, then that changes this sign right here to a subtraction sign. For the cosine addition and subtraction identities, notice that if this is plus, this is minus, and if this is minus, this is plus, so that's a little bit different for that one. And for cosine, notice that it's cosine x cosine y minus sine x sine y, and cosine x cosine y plus sine x sine y. So you need to have these memorized because we're going to be also using these pretty often. We also have the addition and subtraction identities for tangent. So for tangent, notice that it's tangent x plus y here, then this is plus, and this is minus, so tangent x plus tangent y over 1 minus tangent x times tangent y. And if this is a minus here, then notice that this is a minus and this one switches to a plus. So tan x minus tan y over 1 plus tan x times tan y. So again, these are also identities that you need to have memorized. So let's go ahead and use the addition and subtraction identities to find the exact values of the following. So these identities are nice because the addition and subtraction identities allow us to find angles that we can use on our unit circle if we want to find the exact value, something like this, which is the sine of 5 pi over 12. Well, 5 pi over 12 is not on my unit circle. So because this is not in my unit circle, I can manipulate the equation to make it so that I can use the addition or subtraction identity so that it is something on my unit circle. Well, 5 pi over 12, there's a lot of different ways that you can do this. So if I try to do 1 pi over 12 plus something, 1 pi over 12 plus something is not going to give me something on my unit circle because 1 pi over 12 isn't equal to anything. So I'm not going to use that. But if I do the sine of, let's try something else. So the sine of maybe 2 pi over 12. I'm going to use the addition identities because it's easier to add things up to 5 than it is to subtract. I could do subtraction if I wanted to, though. So the next one, 2 plus what gives me 5? Well, 2 plus 3 pi over 12 would give me 5 pi over 12 if I add those together. And notice that 2 pi over 12 is really the sine of pi over 6. And then this would be plus pi over 4, and notice that these two values are values on my unit circle, which is nice. So because of that, I can use my addition identity for sine to come up with the exact value answer that I can have for the sine of 5 pi over 12. So I get the sine of pi, or actually I should write the identity out. So the sine, and let's call this x and this is y. So the sine of x times the cosine of y plus, then we have the cosine of x sine y. So that's what we're doing. So the sine of pi over 6 times the cosine of pi over 4 plus the cosine of pi over 6 times the sine of pi over 4. And then I can now use my unit circle. The sine of pi over 6 is 1/2 on my unit circle, times pi over 4 for cosine is root 2 over 2, plus the cosine of pi over 6 is root 3 over 2, and the sine of pi over 4 is root 2 over 2, because those are in quadrant 1. So 1/2 times root 2 over 2, so 1 times root 2 is root 2 in my numerator, over 2 times 2 is 4 in my denominator, plus root 3 times root 2 is root 6 over 2 times 2, which is 4. And then, of course, since these have a common denominator, I can combine it together. So this would be the same thing as root 2 plus root 6 over 4. And then this would be my simplified answer. And of course, I could check in my calculator the sine of 5 pi over 12 in radian mode would be equal to the decimal value of doing this in my calculator. So I just wrote down here doing the subtraction identities just to show you that I could have done that and I still would have gotten the same answer. So I know that 8 pi over 12 minus 3 pi over 12 is the same thing as 5 pi over 12. So if I reduce 8 pi over 12, it gives me 2 pi over 3, which is on my unit circle, and 3 pi over 12 reduces into pi over 4, which is on my unit circle, so then I can use the subtraction identity. So sine, if I call this x and this y, so the sine of x cosine y minus cosine x sine y. So I get the sine of 2 pi over 3 cosine pi over 4 minus cosine 2 pi over 3 sine pi over 4. And another common mistake that students usually do is they try to make the angle negative pi over 4. This negative sign corresponds to the negative sign in my actual equation, so I don't make the angle negative pi over 4 when I plug it into my equation. So the sine of 2 pi over 3 is root 3 over 2, cosine of pi over 4 is root 2 over 2, minus the cosine of 2 pi over 3 is negative 1/2, and sine of pi over 4 is root 2 over 2. So the first one gives me root 6 over 4 plus root 2 over 4. And notice that this right here is the same as this right here. We just did the subtraction identity instead. So there's many different ways to do these problems, and I could have used other combinations and I would still end up with the same answer. And so I just moved it over so that we can see it all together. So then for B, for this one, I have the cosine of 5 pi over 12. Well, I already know that's 2 pi over 12 and 3 pi over 12 add up to 5 pi over 12, and they're on our unit circle when we reduce it. So I'm going to do that because that was the first one we did. So the cosine of 2 pi over 12 plus 3 pi over 12 is equal to the cosine of pi over 6 plus pi over 4. So then I need to know my addition identity for cosine. So it's the cosine x cosine y minus, because remember sines are opposite, sine x sine y, and each of the angles stand for x and y. So this would be cosine pi over 6 times the cosine of pi over 4 minus the sine of pi over 6 times the sine of pi over 4. And then I know what these are in my unit circle. So root 3 over 2, root 2 over 2 minus 1/2, and root 2 over 2. When I simplify this, I get root 6 over 4 minus root 2 over 4, which is just root 6 minus root 2 all over my common denominator. And that would be my solution. And of course, in my calculator, I could do the cosine of 5 pi over 12 and then see if it matches the decimal of root 6 minus root 2 over 4, which it will. So that would be my exact value answer. So it's kind of cool that we can get these exact value answers using these identities, because we always like to find the exact value because we don't want to have rounding error. So now for this next one, if I have cotangent, well, if I have 5 pi over 12, if I just found sine and cosine, well then I know that cotangent is going to be the cosine of 5 pi over 12 divided by the sine of 5 pi over 12. And if I do that, I know that the cosine of 5 pi over 12 we just said was root 6 minus root 2 over 4. And the sine was root 6 plus root 2 over 4. So we just got to simplify this. So if I simplify this, I have root 6 minus root 2 over 4 multiplied by the reciprocal of the denominator, so 4 over root 6 plus root 2. These 4's end up canceling out to give me root 6 minus root 2 over root 6 plus root 2. Now remember, we don't like to have radicals in my denominator, so how do I get rid of the radicals in my denominator? I multiply by the conjugate, so the conjugate of this would be root 6 minus root 2, and I multiply that in my numerator and in my denominator. So when I do that, I have root 6 times root 6 would be root 12, and then minus, or sorry, root 6 times root 6 is root 36, which is 6. And then root 6 times negative 2 gives me negative root 12, is what I was looking at. And then I have minus root 12 again, and then plus root 2 times root 2 would be root 4, which is just 2. And in my denominator, those are conjugates, so the radicals should cancel out. Root 6 times root 6 would give me root 36, which is 6. Root 6 times root 2 negative would be minus root 12, and then this would give me plus root 12, and then minus root 2 times root 2 would be 2. So then if I simplify this, I have 8 in my numerator. So 8, and then we have minus 2 root 12, which of course that reduces, which we'll do in just a second, over, this cancels out, and this gives me 4. So for this one I get 8 minus, this would become 4 root 3. And then of course we can simplify that even further, and this would end up being 8 divided by 4 is 2, and 4 over 4 would be 1, so minus root 3. So this would be the cotangent exact value answer for this equation that we just did. Now for the cotangent, I could also use my tangent identity. So if we were doing the addition identity for cotangent, I know that is the reciprocal of 1 over tangent. So for cotangent, I could have done 1 over the tangent x plus tangent y divided by 1 minus tangent x tangent y. So if I would have done this, then really I'm doing 1 minus tangent x tangent y divided by tangent x plus tangent y, and this would have been for the cotangent. So you can do the reciprocal of this identity in order to get the cotangent, so that's okay to do. So that's another way I could have done the problem, and then use the tangent values on my unit circle. So for the next one, it says we want to find each. We're going to basically what it should say is simplify each of these. So if I want to simplify each of these, for the first one, we have the sine of pi minus y. So if I use my identity, remember that sine would be the sine of the first angle, so pi, and then the cosine of the second angle. Since this is minus, and then the cosine of the first angle, which is pi, times the cosine or times the sine of your second angle, which is y. The sine of pi on your unit circle, remember, is equal to 0, so this would be 0 times the cosine of y minus the cosine of pi is -1 times the sine of y. So if I do that, this would cancel out, and I have -1, which becomes +1, so this simplifies into the sine of y. I can do the same thing for cosine, so I'm going to go down here. So if this is cosine, and notice that it's minus, so we're doing the cosine of x, cosine pi over 2, and if that's a minus here, this is a plus in the formula. The sine of x times the sine of pi over 2, and then I use my unit circle to help me simplify. So the cosine of pi over 2 is 0. And the sine of pi over 2 is 1. So this is gone, and I'm left with the sine of x. So that would be equal to this up here, just simplified. Now for this next example, it says prove that the cosine x cosine y equals 1/2 cosine x plus y times the cosine of x minus y. So this is when we can use our identity. So we are verifying this algebraically. So I can use those new identities that I just learned. So this would be 1/2, and notice I have cosine x plus cosine y, so that would be cosine x cosine y, and if this is plus, this is minus sine x sine y, and then we have plus, and then again the cosine identity again for now subtraction, cosine x cosine y, and if this is minus, this is plus, sine x sine y. Now if I simplify that, notice I have negative sine x sine y plus sine x sine y, so that cancels out, and I'm left with 1/2 cosine x cosine y plus cosine x cosine y, and those two are like terms, so I have two of them. So I have 1/2 times 2 cosine x cosine y, and 1/2 times 2 is just 1, so cosine x cosine y, and now this side equals this side, so I just showed that those two are equal to each other using my new identity that I learned. For this next example, it says if cosine x is equal to -1/4 and x is in between pi over 2 and pi, which means we're in quadrant 2, then we want to find cosine of pi over 6 minus x. So if I want to find this, then let's go ahead and write that out. So I have the cosine pi over 6 cosine x plus the sine of pi over 6, the sine of x. All I did was put it into my identity. Now, it said that the cosine x was equal to negative 1/4, and I have the cosine of pi over 6 and the sine of pi over 6, which is on my unit circle, so that's nice. The cosine of pi over 6 is root 3 over 2. We were given the cosine of x is equal to negative 1/4, plus the sine of pi over 6 is 1/2. The only thing I don't know is this right here, which is the sine of x. That means I have to find it, given that we're in quadrant 2. So the way that you can do that is you could use the Pythagorean identities if you wanted to, and solve since we know cosine. So if sine squared x plus cosine squared x is equal to 1. So if you wanted to solve for sine, the sine squared x equals 1 minus cosine squared x. So the sine of x would be equal to the square root of 1 minus cosine squared x. If we're in quadrant 2, then we know that all students take calculus. So in quadrant 2, sine is positive. So then I would leave this as the plus for my answer. Or another way that I can find what the sine is going to be is I can draw a triangle in quadrant 2. So if I make my triangle like this, I know that this is the angle that I'm using here. The cosine is negative 1/4, so negative here, 1, 4 adjacent over hypotenuse. And then I could solve for my third side, and for my third side I would get root 15. So then the sine of that angle would be equal to root 15 over 4. And then that's what I could use as well. So either way it works. So this is root 15 over 4. And then all I have to do is just simplify. And as I said, I could have done the same thing with my Pythagorean identities over here, just to show you. So for this one, the cosine squared x right there would have been the cosine of negative 1/4 squared. So then if I would have done that, I would get, I'm just going to do this up over here, the sine of x equal to 1/4 squared would be 1/16. So root 1 minus 1/16. So then that would give me a common denominator of 1 would be 16/16. So this is the sine of x equals the square root of 15/16, which then becomes the sine of root 15 over root 16, which is 4, which is the same thing we got when we made the triangle. Now for this, if I multiply numerator times numerator, denominator times denominator, I get negative root 3 over 8. And over here, same thing, 1 times root 15 would be root 15, and then 4 times 2 is 8. And then, of course, I can simplify this. So I'm going to write it as root 15 minus root 3 over 8. And this is what my answer would be equal to. So again, I had to find the sine of x, I put it into my identities, and then I had to figure out what quadrant I am in to figure out the other example. So for the rest of these problems that we have, we're going to do the next examples in class. So you can just go ahead and stop here, and then, as I said, we'll finish the rest in class.